sum, and I'm using left endpoint. I reminded you about the definition. So, well, the total size of the interval is 8. Therefore, the size of each subinterval is going to be 8 over n. In order to find the left end, I can use a couple of those just to demonstrate intervals for demonstration purpose. But if you're very confident with your answer, you can just find it, use it directly. Basically, the first interval is -2 through -2 plus 8 over m. The second one is -2 plus 8 over m, and then -2 plus 8 over n, and 8 over n, so twice. And the third one is -2 plus 8 over n twice, move on to -2 plus 8 over n 3 times, and so on and so forth. So you can see this is the first, this is the left end of the second, this is left end of the third interval. So in general, the left end of the kth interval, we went over the formulation in class, but for this particular case, it's the left end. Add to the size of the subinterval, multiply by k minus 1, where k indicates the index. So I can plug it back into the function. Therefore, my f of xk star is supposed to be -2 multiplied by -2 plus 8 over n times k minus 1 squared, add to my square is up there. Okay, add to -2 plus 8 over n times k minus 1 and then minus 1. So I definitely want to clean up this expression a little bit because it's quite messy. And I also want to keep track of what I need to calculate. That's delta x. And let me simplify this. This is -2. I have -2. I have 8 over nk. And then I have minus 8 over n squared. Well, the k is what always bothers me, so it's not a bad idea to group those two together and just leave the k term by itself, but let's worry about that later. So what I end up with is -2 plus 8 over nk minus 8 over n, and then minus 1. Like I said, I could have grouped terms a little bit. So it's -2. It's -2 minus 8 over n minus 8 over nk squared plus -2 minus 1 and minus 8 over n. And then plus 8 over nk, this is a k term. Everything without k put together is this, right? So let me put the highest order term out. So it's -2, -2 minus 8 over n squared, minus twice of -2 minus 8 over n times 8 over nk plus 64 n squared k squared, add to 8 over nk plus -3 minus 8 over n. It's a summation of k that's gonna get in our way because that's what I need to handle. So I'm grouping terms based on the order of k instead of just split them as much as possible because there are terms that can be easily combined. So the next thing we are gonna get is supposed to be -2 times the first one. As you can tell, this term has nothing to do with k. And the second thing, -2 times -2, which is plus 4, and then times -2 minus 8 over n times 8 over nk plus -1 to 8 over n squared k squared plus 8 over nk plus -3 minus 8 over n. So this term has no k, this term has no k. I'm going to put them together, which is -2. Well, it's negative of something squared, so I can get rid of the negative sign together. It doesn't affect my answer. -3 minus 8 over m. Okay, that's my first term, which has no k in it. My second term has a k, but it's just order 1. So I'm going to write it as 32, because 4 times 8, 32 over n, -2 minus 8 over m, plus 8 over m. Together, k. So that's my second piece. And I have a k squared term, which is negative 128 over n squared, k squared. So what I have here is f of x k star totally cleaned up. So the next thing is you're going to multiply them together and take sigma summation of it. So when I try to multiply, I multiply 8 over n to it. But even if I multiply 8 over n, I can think on the side. This still has no k. This one has an order of k, 1 order of k. This one has 1 order of k. So the rest part are essentially coefficient. It's the same expression multiplied by k or multiplied by k squared when we do sigma summation. So when I have sigma, k goes from 1 to n. When we get f of x k star multiplied by delta of x, what I could have done is I could have separated all three terms and then factor out the shared expression. So it's a sigma summation, k goes from 1 to n. The first one is this, right? And that term is multiplied by delta x, which is 8 over n. Okay, that's my first one. And then my second one. K goes from 1 to n. I have my second expression here. Don't forget there's a k. And then multiply by 8 over n. And similarly, sigma of negative 1 to 8 over n squared times 8 over n times k squared. So like I said, only the k terms is something that's changing during the sigma summation. Everything else that's not about k, they're constant. Since you're adding a lot of terms with the same constant coefficient, what you could have done is you could have factored out. And summation of all constant term is simply that term, which I'm copy pasting right now, is simply that term multiplied by n. Okay, so just to clarify, this expression, sigma summation of that, is the same as this. Okay, let's move on. The second part, like I said, we're moving the constant coefficient out. So that's my constant coefficient. This is also my constant coefficient. They are all constant. And then what's left is supposed to be sigma summation of k, right? It's supposed to be sigma summation of k. According to the formulation, sigma summation of k is n times n plus 1 over 2. So I actually have n times n plus 1 over 2. Okay, and that's equivalent to this term I just worked on. And then we move on to the third part. The third part, the same idea. Constant coefficient can be moved out. Sigma summation of k squared term. I have a formulation on the next page. So it is going to be negative 1 to 8 times 8 over n cubed. Sigma summation of k squared is n plus 1, 2n plus 1 over 6. If I remember that correctly, let's just take a quick look. Yes, that's correct. So I have all the pieces worked out, right? This is the same as that. So what I need to do is I'm going to have to send n to infinity and see what's going to happen. You could have cleared it up a little bit here if you want to, or you can take the limit while cleaning things up. Either one works. If you were to clean up, say, for example, the n can be canceled right away, right? So what you have is this times 8. So what I'm going to do is negative 2 plus 8 over n squared minus 3 minus 8 over n. The n canceled from here to here, so I have multiply 8 outside. Similarly, there's an n here, there's an n here. Those two can cancel. The 4 and the 8 and 2 can have a 4, and then have n plus 1 outside. So this is 32 over n. Multiply negative 2 minus 8 over n plus 8 over n multiplied by 4n plus 1. And the last term, technically minus 1 to 8 times 8 divided by 6. That's a constant collected. I can cancel one of those n, so it's n squared, and it's n plus 1 and 2n plus 1 on the top. So this is my expression simplified. My final answer is supposed to be limit of that whole thing. So I'm taking limit by sending n to infinity. So if I take the limit, n goes to infinity, the first term, you can think about it very quickly, that if I were to copy paste it here, you can do a quick substitution. It's like negative 2 times 2 plus 8 over infinity, which is 0, minus 3 minus 8 over infinity, which is 0, multiplied by 8. So it's negative 2 times 4, which is negative 8, minus 3 times 8, which is negative 88. That's my first expression. And then let's try to look at second expression. I'm supposed to take the limit of the whole thing, so it doesn't hurt to take each one at a time because it's simply too long to write. So if I'm looking at this expression, well, you have different ways to look at it. It has two parts, so technically you could have combined it a little bit. Well, first of all, direct substitution doesn't work anymore because you will end up with 0 multiplied by infinity. So we need to clean things up a little bit before we consider how we can freeze it. It's essentially a polynomial over polynomial. So what I can do is I can have limit n goes to infinity. The first part is 32 multiply 32 over n multiplied by negative 2 minus 8 over n times 4n plus 1. The second part is limit n goes to infinity. It's 8 over n times 4n plus 1. So I split it into two parts. The first part of it can be write a little bit more prettier. It is 32. Let me do this before I try to write it a little bit prettier. It's negative 2n over n minus 8 over n, namely negative 8, negative 2n over n. So I can write it as 32, negative 8 minus 2n, 4n plus 1. And the denominator is n and m, right? So this is how I can freeze the first one. The second one is going to be 32 n plus 1 over n. Well, if n goes to infinity, you can consider L'Hopital's rule, or you can use what we learned about limit at infinity. Clearly, the answer is 32 here. For this particular problem, you can consider use L'Hopital's rule, or you can use what we learned earlier about finding the leading term divided by it simultaneously on the top and bottom, and so on and so forth. So bottom line, the leading term is going to be 32, negative 2, and 4. The highest order is n squared on the top, n squared on the bottom. So it's the ratio of the leading coefficient. So you have 32 times negative 32 plus 32, which is the second part of it. And let's move on to the third part. You do remember we had part 1, part 2, and part 3, right? We did part 1, we solved part 2, and now we need to solve part 3. So I'm taking limit, n goes to infinity, for the structure which is negative 1 to 8 times 8, n plus 1, 2n plus 1, over 6n squared. Well, along the same line of thinking, it's negative 1 to 8 times 2, because the leading term is n squared on the numerator. This is a coefficient. And then it's 6 down here, so that's a limit for the last term. Well, because I'm not testing about finding the limit at infinity here, so I'm basically using whatever rule I can use here to do the calculation efficiently. If in the test, I'm simply asking you, please find the limit at infinity. And I stated you cannot use what we learned from pre-calculus. Then you cannot take the shortcut. But for now, you're good. So we have 3 parts, and they're supposed to be add together. So my final answer is this, add to that, add to this. Notice that I didn't really do simplification because I don't want to waste too much time on it. And you can see this answer clearly is going to be negative. So I try to mention it one more time. It does make sense if you have the net area, the definite integral to be negative, because area values could be below the x-axis. In the definition of net area, it's going to be considered as negative. Hope it helps you to understand the Riemann sum idea a little bit better.